So we wanted to have a program that checks, that is given an array, and then it checks if that array is a Latin square. We said that a Latin square, that means an array has to be a square, which means the same number of columns and rows. Then they should contain the values from 1 to up to the size of that array. We cannot contain values greater than that, with no repeats on either the rows nor the columns. So let's try to do that step by step, starting from the easiest part of it until the other one. Okay, we wanted to have a program that do that. Did I tell you to use a class, a method, something? Well, we just would like to have something that is given an array, and then it checks if it's a Latin square. I mean, the minimum thing that I can think of is let's have, for example, a two-dimensional array. I name it array equal, and then I don't know. Let me put some values inside of it. 1, 2, 3. 1, 2, 3. 3, 5. Okay, 3, 4, 5. Whatever. So this is my array. So you can see that this array. Maybe let me enable this. This is not a square, yes. So, but my program should be able to catch that if it's not a square. So this array is what? I mean, let me move it there. We don't have a lot of things to do there. So, yeah, we would like to have something that will either display. Would like to have something that either displays, tells us that if it's a Latin square or not. Maybe what I can do something. I can have something to check. This is one way to do that. There are many different ways, but check Latin square, which is a method that I'm going to call, and in that method I'm going to give it the array. And then, of course, this is not working because I did not define this method, but imagine that if this method, I'm using it here, it is going to return, let's say, a boolean. If this is true, I'm going to display the array is a Latin square, and if not, I'm going to display the array is not a Latin square. So there are many different ways. I chose to use this way. You can also display this inside of the method if you'd like to create, or maybe create another class, and in that class you create another method, whatever. I just would like to go for the simplest way to do it, and this is, for me, one of the simplest ways. Okay, of course this is not going to work because NetBeans is complaining that this check Latin square cannot be found because it doesn't exist. I need just to create it. And actually, since this is called just from the main, it has to be static, because the main is static, and all the methods that are called within a static method should be static. So that's why I'm doing something like this. I'm returning a boolean, and this is the name, and it takes as a parameter an array of ints. Let's name it A, for example. And I'm going to return something. Okay, let me show you something that I always do when I'm returning, having a method that returns something. This is what I usually do. I declare a variable and I name it returned value, for example. And let's say I put any value inside of it, for example, false. And then I'm going to be doing something, and then at the end I will return the returned value. Okay, so in the between, I'm going to be doing something if I need to change the value that I'm returning. So I'm assuming that the whatever you give me is not a Latin square. So if it is a Latin square, then I'm going to make this become true. So if this is true, this is Latin square, the A is a Latin square. If this is returning false, this is not a Latin square. I can make it true and then change it to false whenever there's one condition which is not met, which might be more simpler for me to do, for example. Do you have any problems with this? No? Yes? Fine. I'm just declaring a variable and I put a value inside of it, and I'm going to be doing something in between. And if I'm going to check, actually I'm going to check a lot of different things. What are the different things that I need to check? First of all, check if the array is a square. This is the first thing I need to do. The second thing, check, well, maybe check just the values. If all the values are less than the n, for example, check the values are 1, 2, up to n. Because I don't want to have some values greater than n if n is the size of my array. Okay, in my case, this is actually, anyway, n is a.length or ai.length. Remember? N, what is n? The number of columns or number of rows. And anyways, I'm going to check that anyways. So this is the first, the second thing. The third thing that I need to check is, check if there is no repetition in the rows, and I will need to be doing the same thing again for the columns. So notice what I'm doing. I'm just preparing just the different steps that I need to go through to make sure that my method is going to return the right thing. So if one of these is false, that's it. I don't need to continue doing it. But anyway, then this is something that if one of those things is false, I'm going to do something. Okay, so for this, maybe just to simplify that, I'm going to return true if I'm not going to use this one. I'm going to return true if I pass all through these checks and there were no problems, and if in one of those cases I find myself that there is a problem, I will return false. With the return false, I'm not going to continue and check the rest. It's like the break for the switch. I'm going to check one by one. Once I find something which is not respecting the rules of Latin square, I'm going to, okay, that's enough. If this is not a Latin square, return false. No need to continue and check the rest. Is this fine for you, with you? Okay, more feedback, please. Yeah, and faster, because we don't have to record the long silences. Okay, if you have some questions, please. This is one of our last lectures, so there's no more time for you to postpone your questions to after I'm going to do the review, whatever. Well, do ask your questions now, and later on, if you have other questions, ask them after, and there's no problem. So, but ask now your questions.
Why do you use static?
This is a good question. Why did I have to use? If I don't, it is going to tell me, well, sorry, non-static method check Latin square cannot be referenced from a static context, which means this is static, the method main is static. I'm calling this method check Latin square from a static method. Therefore, this static check Latin square should be static. This is a rule. Yes.
My program already to the user to enter two-dimensional array square. That in my.
Okay, if you ask the user to enter those, that's okay. That's fine for me. But I don't care. I mean, I'm not interested in that. I know that you can do it. What I want you to do is to do the work that is done here inside of this method. So entering this from the user, that's fine.
I mean, the user will enter a square, already square.
No.
Oh.
Well, this is done. This is not. Then you're forcing your way into accepting only square. Square arrays. Well, this is not false, but this is not complete. This is an incomplete answer to the first question. Yeah. Okay. Any other questions? So, how can I check if the array is a square? So I have to check a dot length. This is the number of rows. This is the number of rows. If this is equal to a0 dot length, then this is square. Okay, so but if this is not, so if it's true, and if it's true, I'm not going to return true because I need to keep checking the rest. So, but if this is not respected, actually this is going to be false, right? So if just the beginning you give me a non-square array, I'm going to tell you, well, this is not a Latin square because it's not even a square. So this is one thing. When I'm doing this, I stopped a little bit because I was thinking about, remember we've seen some rugged arrays, which are arrays that have rows with different lengths. So if I'm doing this, actually it is going to be very simple. I'm just checking the first one. But if I have this rugged array, well, I need to be doing some more processing. I don't want to complicate that. I was not expecting you to work with rugged arrays, so I'm assuming, but I just would like you to have that in mind. I'm assuming that this array is not a rugged array, which means it just have the same number of columns in each row. I don't have some that have more than other columns. You understand what I'm saying, right? I'm not going to address that because I don't want to. I didn't want you to go into that level of details, anyways. But I'm telling you that just in case you would like to be doing some more complete answer to this question and you would like to work with rugged arrays, well, I need to check actually not only for 0. I need to check for all the different rows that I have in my array. But now I'm assuming that this is not a rugged array, and if the column number of rows is different from the number of columns, I'm going to return false, and this is not a square, so this is not a Latin square. Okay, this was easy. Now a little bit more processing. I have a warning. I'm always curious to see what is the warning. The if statement is redundant. Yeah, but okay, just get out, because it assumes that there was no code happening. So I'm not going to be paying attention to this one, because it's going to be removed just after I start typing the next code for checking that the values inside my array are respecting that order. Okay, just to simplify things and to use the same type of checking that I'm going to be doing, I need now to check for every value inside my array if it is less than or equal to n, and in our case n is a.length, for example. So I need a for, and look what I'm going to be doing. Just to simplify things, I'm going to declare int n equal, what about this? So this is my n, and now I'm going to use this n over here to see if I is from 0 less than n, and then I need to do another for up to n, and now I need to be doing some checking. Okay, so how can I check? I need to do some if my array of j is less or equal. Actually, I'm more interested into finding if it's not less or equal. If it's not less or equal, then I'm going to return false, right? So if it is greater than n, if one of them is greater than n, return false. Very good. what I did now, I'm just checking if the values are greater than n. But actually, I need to check also that they should be less than, they should not be less than 1. So I'm going to need to add something else. Help me in the content. So what should I do? Or. So if the value from the array is greater than n, or the value from that array is lesser than 1, which means it can be 0 or less. Remember, I'm just using int. Why am I using int? Because nobody told me what is the data type of that square, right? So I can choose whatever suits me, and the int is the easiest one I can use, so I'm going to use it. So now what I'm doing, I'm checking if the number, one of the numbers in the array is greater than n, or one of the numbers is less than 1. I'm going to return false because this is not one of the, respecting one of the conditions of the Latin square. So this is because I need to go for each of the elements of that array. Why did I use what? And? Well, because no number can be at the same time greater than n and lesser than 1 at the same time. Because and means this has to be true and this has to be true. While if one of them is true, that's enough for me. If you have an array and one of the numbers is -1, then this is not a Latin square. But if I put and, it has to be -1 and it has to be greater than n. Well, that's impossible. So it is never going to be true. That's why it has to be or. So it is greater than n or it is less than 1. Okay? But this is my, let me just put this 4j and this is 4i, so it's going to be clear. Alright? Now the other part. I just would like to check if there are no repetitions and among the rows, for example. Okay, how can I do that? So I need to let me just try some tool that I have, this new thing that I can use from here. Where is it? This pointer. Okay. Where is it? Oh, here it is. Oops. Let's erase all and go back here. Okay, so what I can use something, just a pen. Okay, this is my array. Another one. That's too bad, I need to click every time. But anyway, we'll do it. So now I'm assuming, because I'm here, I'm assuming that my array is a square, and then I'm assuming that all the numbers within that array are between 1 and n included. So what I need to do, let's check for the first row, and then I'm going to be doing that for every row. So what I need to be doing is check one number. Let's say I have 1, 2 and 3, and then I have like 1, 3, 2, and then let's have this 3, 2, 1. Yes. Yeah, I know. I just would like to check that there are no repetitions within the rows and then within the columns. But let's continue from here. I just would like to keep this running, which is interesting. And then now what I need to do, because I finished with this one, right? I check that all the numbers, if I pass this stage, that means I never returned false. So I'm good. I can continue and check the last two conditions. The first of those two conditions, I need to check for each row if the first element here is not repeating. How can I do this? I have to take this one and compare it to the next one, and then this one compare it to the third one. So is this enough? Well, no. I have to go now for the second one and compare it with the first one, and compare it with the next one, and then every time I need to compare each one of those with the rest. So I need to take one of them and compare it with the rest. It should not be equal. So how can I do that? I need to define another array. Okay, so what are you going to be doing with that other array? Okay, you copy the other array. Okay, you have two copies of that array. So what are you going to be doing then? Well, let's do something. We'll have a lot of things. Let's try to just start with the first one. How can I check if not the content of this first one is not repeated in the rest? What I need to be doing, of course, I always need a 2 for loops. Why I need 2 for loops? I mean, okay, maybe for the first one I need only 1 for loop, because I'm going just to compare this with the rest. So let's see if a of I and j. Oh, this is going to complicate things, because now I'm checking this one and going back to the line and going to check the other one. Let me do something. Let me just simplify it a bit. Imagine that I'm not using this. I'm using only for the first one. Okay, I'm not putting the code to solve the whole problem of all the rows, but let's check only the first row. Okay, for the first row, if I need to compare, let's do it. Even though, let's not do any for loop. If I just would like to compare, what should I compare? I should compare A0, 0. It should be different from A0, 1. Right? And then I should have also, okay, this is, let's do something like this. If I have, okay, I'm just trying to write here, and I have to have this A00 different from A02. So what I did, I just compared this one with these two. What would happen if I have more than 3 columns? It's just I will keep going. I will keep going and comparing the rest, right? So you can see that I'm comparing A0 with all of the rest. But is this enough for me to say that, okay, there are no repetitions in this one? Okay, very good. Now I need to compare the second one. Okay, maybe let me try something just to make it a little bit bigger. I just would like to make it a bit bigger because I would like to show you something. Which, oops, oh, I can move that. Okay, and then Alaikum Salam. Why am I doing this? Because I would like you to realize something. And the thing that I would like you to realize is, and let me put something here, for example, like 2, another 2, just for fun. And 3, 4, 4, 1. Okay, I just would like you to realize that if let's copy and paste, and then have this is 3. You agree with me that now I check that the 1 does not repeat? If I need to check the second one over here, do I have to check it with the previous ones? I don't need to check it with, what I need to check now I just need to check now this one against the 2 and the 3. Do you agree? This is 0, 1, 2, 3. I'm comparing the first one. I'm comparing this one, 0, 0, with 0, 1, with 0, 2, with 0, 3. If they're all different, that means, okay, I need to keep on checking. Now the second one, this is 0, 1. I'm check it with, is it different from the third one and the fourth one? Do I have to check it with the previous one? No, because I already checked it, that this one is, for the previous one was already there. And then for the last one, I need to do the same thing. I need to check it now. This one over here, this number 2. Check it that this is different from the third one. I intentionally did this because I would like you to notice that what would happen if I'd like to check this for the next row. So this is first row. For the second row, this is the verification that I need to do. But instead of having 0, this should be 1, 1, 1, 1, 1, 1. As you see, there's something that I can just make repeat, and this is the same thing. Now what I'm doing, I'm just checking this 1, 0, comparing it. So I'm comparing this 1, 1, 0, compare it with 1, 1. And then I need to compare 1, 0 with 1, 2. 1, 0 with 1, 3. And then, okay, I finished comparing this number 1 doesn't exist. Okay, let's compare now this one. 1, 1 over here, compared with 1, 2. And then 1, 1 compared with 1, 3. And then continue, compare 1, 2 with 1, 3. And as you can see, the first row, second row, there's something that I can put in a loop. The first thing you notice that this 0 can be put in a loop, right? So let me do something, and I'm going to be doing this in a 4. I'm going to construct my 4 just step by step, so just bear with me. So int I 0, I less than n, and I plus plus. And I'm going to put all these into a for loop. Okay, so this is going to be my for loop. Of course, this is not working code, but I'm just building it, okay? So this is my for I. And I now is going to be replaced, all this first part is going to be replaced by I, because the first time I is 0, I is 1, I is 2, until I is n. Now I'd like you to realize that here also I can do another 4, because you see this is 0, 1, 2, and this is 1, 2, 3, 1, 2, 1, 2, 3, and then 2, 3, and then 3. How can I do this? Well, let's have another 4. Let's name it j, n, because it's a maximum, we cannot reach 4. Now the problem is, do I always start from 0? So the first time, this is going to be 0, 1, 2. Okay, so this is going to, not to try to do everything at once. This is 0, 1, 2. So I'm not going to 3, because if you realize that this is 0, 1, the indices are 0, 1, 2, oops, 2, and 3. So my n is equal to 4 in this case, right? So n, this is the only problem with this pen, is that every time you leave, n is equal to 4. So that means it's less than 4, it's going to become the last value of j will be, in this case, in this 4j, the last value of j would be 3. The last value of j, what I'm going to enter, is going to be 3. Do I need this to be 3? What is the last value of this? 2. So I'm going to put n minus 1 instead of having just n. Why n minus 1? Because I don't want this to go up to 3. So now what I did, if I move this inside, can I replace this with j? Now j becomes 0, then it becomes 1, then it becomes 2 because of this. But my problem is that, you know, I'm checking this and the first time is 1, 2, 3, and then 2, 3, and then 3. I'm not going to keep all this j, because now j was 0. I don't want this to be on the same j. J should be j plus 1. So how can I do this? I need another 4 for that second one. And what is that other 4? I'm going to use for k, but that k should be less than, what is the maximum for k? 2, which is, well, n minus 1. But what is this k is all about? Why did you say 2? I disagree actually with you with the 2, because now what is not repeating is this 1, 2, 3, 2, 3, and 3. I don't want this to be checking the j here is going to become here in this second for the columns. So j is going to be 1, 2, 3. But however, the way it is now, I cannot put all this in one 4 because it needs to check that this is different than each one of those. So I need to ask now the question is that if I of I j, if it is equal to a of I, and what I'd like to do, we have this k over there, and this is the k that I would like to use. If this is equal, then I'm going to return false, because I know that they are on the same line and I don't want this to happen. However, this k is not starting from 0. The first time it starts from 1, second time it starts from 2, and then the last time it goes to 3. So it cannot be n minus 1, because n minus 1 k will never be 3. So I don't want it to start from 0. I don't want it to start always from 1, because the first time it starts from 1, the second time it starts from 2. But I have something that is j plus 1 that I can do. And now with this j plus 1, I would like you to realize that when I is equal to 0, okay, I is equal to 0, I get inside, and then what I'm going to be doing is and notice that this is k now. What I'm going to be checking is that 0, then j is becoming 0. When j becomes 0, k becomes 1. And I'm checking is a0, 0, is it equal to a0, 1? Then I'm going to increment k, k becomes 2. And I'm going to check if a0, 0 is different from a0, 2. And then k becomes 3. Is a0, 0, you notice I and j did not change, and checking now its k is equal to 3. Okay, that's interesting. Let's find out what would happen if now I'm finished this. K becomes 4, 4 is less than 4, no. I get out, and then j becomes 1. So now this is 1. So this where all j were is becoming 1. I is still 0, but now I'm checking with k and put k is equal to j plus 1, 1 plus 1, 2. So you notice that what I'm doing? Now I'm comparing 2 with k is equal to 2 and 3, and then the same thing, I'm going to be comparing all this. So I hope that I convinced you that this is the 4k. It had to start from j plus 1 because every time I need to compare with the rest. And by only for one, no, for all the rows, because now I is going to move. I is for the rows, so for the row 0 it's going to check. So this is for one row, and then for each row I'm going to change this I, and then it is going to check the rest. So now I'm checking for each row if this is different. If one of them is equal, if on the same row if they're equal, one of them is equal, then it's going to return false, and that's it. If so, for example, for this one nothing will happen. This one, it is the one is equal, so it's going to return false. And we're going to experiment that by using different arrays, so we're going to test them later on. But I just would like you to realize that this is what I need to do. The only thing that we added is that this 4k, where it had to start from j plus 1 and stop at n, and of course the j had to start at n minus 1. So because j, we only compare this with the next one. And actually, if you noticed, this k, what it does, it compares. Remember when we compared the first one with the rest, and then we went to compare the second one, we started by comparing the second one with the next after the second one. So the second one is like, let's say for j, but then we started comparing that with k, which is the one after j. So the one after j, and then we kept comparing until the end. And the j stops at the one before the last. That's why we put this minus 1. What I wanted you to realize, I didn't want to put the code right there and then discover it and try to understand it. I wanted you to understand how we construct the answer by trying, first of all, to simplify the question. We didn't know how to do it for the whole array. Okay, let's do it only for one row, and let's hard code it, and let's put the conditions one next, all the conditions that need to be met for that row to be valid. And then when we did that, we try to generalize by putting noticing that there's something that repeats. Okay, let's put this in some sort of a for, and then we try to find a way on how to deal with that. Maybe this is the only surprise that came for you, for those who did not finish this exercise. So now that I did this for the rows, how can I do it for the columns? If I'd like to compare now for the columns. Well, I will have to do something similar, okay? But we need to be doing something. Okay, first of all, let's try to, we have the I. Now the I is going to be our columns or our rows? Our rows. Okay, the j, let's keep them. So to n. But if we're comparing with n is the rows, right? I is our rows. We need to compare from 1 to n or n minus 1. The I is always going to be from n minus 1. So if we'd like to go column wise, actually this is not the 0, 1, 2. This we should stop here. And then the way we did it, we are doing it like that is not the right way. So actually, what we can do, we can just copy the same thing over here. I mean, this is the simplest way. Except that now, instead of looking for ij, we look for ji, and instead of looking for ik, Okay, you're lost, right? Let's see. I just would like to run this and put some values. Maybe I don't know how to put them values in there, but let's put some values. I is equal to 0. What I might be doing, let me just grab a screenshot. That was not what I wanted. Okay, I wanted this one over here. And let me take this screenshot like this. Okay. And now we don't need that one, so let's erase everything. Yeah. You're missing the critical part, but yeah. So, unfortunately, I didn't get that array. Anyways, so now we're going to follow the I, J, and K. What is this? And I'm going to draw my array. And in my case, n is equal to 2, and I have all these. And I just would like to compare something with, see what is going to be compared. So this is 0, 1, 2, 0, 1, 2. My n is equal to 3, and this is n. Put 0 in I. Put 0 in j. So this is 3, this is 2, and this is 3. Now what I need to check is k is equal to j plus 1, which is k is equal to 1. I'm comparing a, j, I. A 0, 0. I'm comparing it with a 1, 0. So I'm comparing these two, which is okay, right? Now k becomes, because I finished whatever, if they're different, I'm going to go up, and when I go up, I'm going to increment k. K becomes 2. And now I'm asking, is 2 less than 3? Yes? So now I'm comparing 0, 0 with 2, 0, which is, I'm comparing this one, 2, 0 with this one, and I'm comparing these two. K becomes 3. Is 3 less than 3? No, we get out and we find ourselves in the end of j, so we're going to increment j. J becomes 1. Is 1 less than 2? Yes, we get in. K becomes
1.
No. What is j? Because k is 1 plus 1. So this is becoming 2. So now k becomes 2. And I'm comparing j, which is 1, 0, with 2, 0. I'm comparing 1, 0 with this 1, 0. This is 1, 1, 0. Yeah, I'm comparing this one with 2, 0. I'm comparing these two. Does it make sense? Yes, because actually we finished comparing this one with the rest, but we have to compare this second one with the rest. And this is what we are doing. So now we moved on until comparing this thing. What would happen now? K, I'm going to increment it, it becomes 3. Is 3 less than 3? No. Get out. Increment j, j becomes 2. Is 2 less than 2? No. So we're going to get out and fall back to the 4i, and then we going to increment I becomes 1. So now we're going to back to the second column, and then you guess that we're going to be comparing this one with this with that one, this one with that one, and then this one with this one, and then we finish. So this is the only thing that we had to do in order to. What happened? Did I close NetBeans without noticing? So the hardest thing to find was this. I mean, NetBeans just crashed, I think. The hardest thing to find is what was the first one. You see, this it crashed. It did not save. The second one, I just need to realize that I just need to swap those things over here. Now this is, I'm checking the repetitions within the columns, and if one of them, and if you notice, I'm checking if they are equal, because if they are equal, there is a repetition, then I'm going to return false. If they are not equal, then I'll keep going, and then I will return true at the end. So that if I reach this stage, that means all conditions are met for a Latin square. So let's just check if this is working. I'm going to try this with this one. If I run, of course, it should not be Latin square. So there is not a Latin square. Okay, let's just now make it square. Oops. Let's make it a square. Control C, VV. Okay. Let's make it a square, but of course the values are not going to be respected, and this is not a Latin square, but this time because of this repetition. No, because of the values, because this is the condition of the values that stop it. Because I'm checking if this is all of them are less than n, or so let's, for example, the n is 3. I cannot have 4, but I can have 2 and 1, and I can have 1 and 2, for example. And just to see my array better, I'm going just to do it this way, so you can see actually the array in a better way. So you can see this is my array, and if I run it now, is it a...
The second one we have.
Okay, what would be interesting just to see something that said, okay, passed the first condition. Just so you can see actually which one was not respected. So when I pass the first condition, I'm going to display this. When I pass the second condition and the third condition, I don't need to display that for the rest, because if it passed the other one, it's going to display it's a Latin square. So passed all conditions. So let's run this and see which one. You see, passed the first, passed the second, passed the third, and the third condition was passed, but fourth was not passed. So it passed all of them because there are no repetitions on the lines, but there is a repetition on the columns. That's why it didn't respect that. What about if I put -1? It passed the first condition because this is a square, but it didn't pass the second one. And now if I'm trying to do something which should be a square, let's do something like this: 3, 1, 2, and then we have like 2, 3, 1. If I run, pass the first, second, third, and this is a Latin square. So this is one way of solving that problem. I mean, the straightforward way to try to solve it. There might be some more interesting ways, but this is the simplest that came to my mind as of now. Any questions? This is the simplest, yeah.